This video will give examples of careers in precious metals using statistical analysis, physics, analytical chemistry, civil engineering, mechanical engineering, chemical engineering, metallurgical engineering, and others. Bulk lots of materials for sampling come in many forms, from mixed solids like crushed ore or scrap circuit boards for recycling, to sludge, slurries, and solutions from industrial processes. A true sample is a small sample of a mass which represents the average composition of the mass, or simply stated, truly representative of the bulk. Uniformity of composition and particle size of the bulk material are the key features which lead to selecting the processes required to generate true samples. To maximize uniformity of composition, bulk materials are most often processed prior to sampling. For example, scrap metal lots are melted to form alloys or leached to take all of the metals into solution for analysis. When the bulk contains solid particles, homogenization or mechanical mixing is the sampling technique employed to create a uniform distribution of particles so that each sample taken from the mix will represent the average composition. The uniformity of composition of the starting material greatly affects the amount of reduction needed for a true sample. Highly uniform materials require less reduction. A fundamental principle of good sampling is to gradually reduce the bulk simultaneously with a gradual reduction in the size of the particles. Larger sample sizes are required with larger particle size distributions of the bulk. Therefore, it is of great value to crush and grind the sample to allow for taking smaller, reliable samples. The sample is then mixed thoroughly to obtain a mixture that is homogenized. For example, when salt is completely dissolved into a solution, the solution is thoroughly mixed so that any droplet will contain the same concentration of the dissolved salt. In order to get the same amount of thorough mixing with solid particle mixtures, the solid particles must be ground small enough and extensively mixed prior to sampling. Each type of material for sampling and analysis has optimum ratios for the fineness relative to the size of the sample. These ratios must be determined experimentally. Milled, blended, and split test samples are taken from lots and sent for analysis. Assay samples are then taken from the test samples, which typically require further grinding and splitting. There are a number of traps that can produce misleading results that care and handling should avoid. Cross-contamination from one sample to the next could occur if sampling equipment is not cleaned adequately between lots. Care must be taken to collect all of the dust when crushing, grinding, or handling fine materials, as some dusts have different metal concentrations than the bulk. Fine particles may also pick up or lose moisture while passing through sampling equipment. Although they may not appear wet, they may contain enough moisture to affect results, so this should be accounted for. When samples reach the assay lab, they may have segregated, so the test sample should also be blended again and split properly. The IPMI recognizes the importance of this technology to the precious metals community and has published and made available several books on this subject. The Sampling and Analysis Committee of the IPMI also publishes guidelines in this field. Our next videos will be on the various analytical techniques. The International Precious Metals Institute promotes the education and advancement of precious metals technology and business. IPMI is an international association of companies committed to providing technical resources and educational materials, including a series of videos presenting examples of precious metal applications and a variety of interesting and rewarding career opportunities.